and how we wanted to bring a conclusion to that. So far, what we decided was credential rotation using access tokens, which is a access key and secret key. It just makes the design very complicated, and given that right now even the cloud providers do not support that form of authentication, and also given that we can do it in a much simpler and cleaner fashion when we use service accounts, I think the decision we made to not do credential rotation for access keys um, is a is something we can stand behind. Um, I just wanted to open up with that to give everyone a chance to also comment on it. Any thoughts?
Yeah, in the interest of getting to alpha, it seems like skipping over that is a good idea.
Mm-hmm.
Agree.
Okay. So in
Can I
talking
ask
about
though, what do you mean with when you say service accounts, right? Then you mean that in a similar model to the token, to this secure token?
yeah. Yeah, so yeah, STS, yes, secure token service, yes. So I looked up, I looked into it a little bit more. I haven't looked it up for anything other than AWS yet, but it looks like the token refresh request is actually done by the client, and the client always talks to the link local IP address, which is 169.254.169.254, and asks there's a particular endpoint it hits, HTTP endpoint, and asks for a new token, a new session token. The access key and secret key remains the same, but then the session token keeps getting rotated. And in order to access the backend, you need all three. I don't know if that makes sense.
And what is the fixed address for?
Okay, so the fixed address is um, in EC2. If you're running any workload on EC2, EC2 can be created with some roles. The fixed address is local to that machine, or in our case that pod, and whenever a workload hits that endpoint, the HTTP server that responds to it responds according to who made the request. So in this case, it would give you credentials for that specific pod that made the request.
Okay, and how does that extend to other
Other
cases?
How does it? Yeah, I don't know about other vendors yet. I have to still understand that a little bit more. But with AWS, I was able to spend some time, and like Vianney was mentioning last time, STS is the way to go about it. But there are some restrictions with STS also, which is you can only create credentials with expiry of 12 hours or 24 hours. So yeah, there's a little more discussion needed, but things are still possible given that if the client is the one originating the request for refreshing, um, it solves that problem of how does the client take the new credentials. And secondly, if given that service accounts can be rotated in Kubernetes, we have an actual mechanism for putting new tokens in there and having something like 169.254 169.254 always return the latest one. So
So
yeah,
maybe I'm missing something about this. Sorry, one second.
no problem. Shing, are we recording? Okay, good.
Sorry, I wanted to ask. So when um, when we are minting credentials within Cozy, right, and providing it to the workload, does that process have to change somehow to support that, or is it just by having the endpoint? So essentially, I don't even need to pass on the credentials, right, to the workload. It just needs to be available through that endpoint. Is that kind of
Yeah, something
the
like
model?
that. So yeah, so the clients for AWS at least have a mechanism where they talk to instance roles, which is that link local IP address, to figure out what its credentials are and what its access is to a particular resource.
So there's going to be a protocol that's somehow AWS specific that clients can request if they want this functionality.
Well, I have to see if it's just AWS specific or other clients also support it.
Well, yeah, that would be the sticking point, I think, is users need to, if users want that particular functionality, there has to be a way to request it in a way that they will be guaranteed to get it. So if it's AWS specific, that makes perfect sense to me, that there would be an AWS protocol that you'd ask for and you get it and it would work. But if we want to glom this onto the S3 thing, then we have to have some sort of a capability probing mechanism to say, can you do it, yes or no, and then you can ask for it in your bucket class, and yada yada, to do the whole negotiation.
Yeah, that makes sense. It looks
But
like
I'm also not clear on how this works. I mean, with the current bucket access design. I mean, what happens with the rest of like the bucket access flow, the bucket access request and the response, is that even relevant?
So for the protocols that are meant to depend on some sort of built-in token that the pod just has, then yeah, the bucket access is just an identifying the principal that's supposed to have access, so that can be granted by the back end, and then everything else is just supposed to be handled through your regular token. So yeah, you wouldn't have to provide any credentials down to the workload if it was like GCP or AWS or Azure, one of the cloud provider style protocols.
yeah.
Yeah, I mean,
So
it can be implemented in any platform, but I mean, the same model can be implemented. But the question is, if then are we saying that the bucket access model is somewhat of a
Well,
temporary? Yeah,
it's not clear that the model could be implemented because it's this is to the extent that you're running in an environment where your actual pod security tokens are identical to your object storage access tokens, and that wouldn't be true anywhere other than one of the hyperscalers. Like I may want to use GCS bucket storage from my on-premises Kubernetes cluster, and my on-premises Kubernetes cluster isn't going to have Google security tokens for all of my pods, right? It's just going to have whatever I set up with my Kubernetes distro. And so in that context, I'm going to have to use some other protocol to talk to GCS, probably the S3 protocol. And in that context, I'll be using access keys and secrets and the regular way of doing it, because there's no way to, like, unless you get like GKE on-prem, which I think is a product they have, you can't get Google's security tokens that are identical to your GCS security tokens in your Kubernetes cluster. It just doesn't work that way.
mm-hmm.
yeah, I mean, yeah, uh, the clouds specifically they have it, but in GKE they have that. So in GKE, a pod is associated with a particular security token. What that means is if any request is made with the security token of the pod, which is not necessarily the same as the GKE token, if the security token of the pod, then it is understood that it has the same role as what was defined um, in the equivalent account for that security token. For instance, like if I create a pod with a security account, whatever, like security account 1, someone in the backend associates that with a role in GKE, and any request going from that pod will have the security token that it always has, and uh, GKE knows how to GKE knows how to associate that token with a role that's been defined in it, and
Right.
uses that
That's
to.
the STS assume role kind of call, right?
Yeah,
Right, but in the general case, you don't have unified IAM between your Kubernetes cluster and your object storage.
absolutely, yes.
So you need something else, and that's what the regular S3 with the access key and secret is for. I don't know if there's going to be other flavors of unified IAM other than the ones that the hyperscalers offer, because it seems like it's unlikely to happen in general that you'll have a Kubernetes distro and an object storage solution provided by the same company with unified roles
But
and everything.
but what is the problem? I mean, it's not even if the identity management is provided by the storage itself, that can still be provided by the storage. I mean, even if it's not provided by the cloud, it still has meaning.
But it would have to be the case that Kubernetes would be using the same tokens as the storage.
No,
for
it just
this.
needs to be, it needs to translate these, right? The request there is to assume a role based on your token, right?
Yeah.
Well, if you know of a way to do that, maybe we should have like a prototype demonstration or something to say like this is a way to unify these things so that you don't need access keys and secrets.
Yeah.
Because
So
it's not obvious to me how that would work in a real world deployment.
instead of returning access keys, secret keys, we could return an OIDC token, and the pod could directly assume the role with web identity, for instance. So it would be the same, basically, bucket request.
I think Ben's asking, yes, that's one possibility,
Yeah.
but we need something that works across the board. Either we should implement it, or it should be something that's so universal that we can rely on it.
And the thing is, S3 itself is specified in terms of access keys and secrets. Like to go to this level where you have some other token that grants you access implies a dependence on another thing that is not S3 and is not Kubernetes. And so we got to be careful about adding dependencies on other things.
But Kubernetes does support OIDC, right?
What is OIDC?
Open Identity Connect.
Yeah.
Is that built into Kubernetes?
No, it's a standard for authentication and authorization. So I think all the OAuth providers are OIDC compliant. It's just like a standard for authentication. So it's like the protocol, I believe. Yeah, that's as much as I know about it. And I know Kubernetes supports the protocol. Go ahead.
So for instance, if you have an identity provider inside your cluster or outside, let's say, your storage driver can be trusted, okay, and ask for a specific OIDC token for the bucket, and then return this, and the pod can use this token to access temporary credentials. And then it's up to the application to renew the tokens and stuff.
Right. But this is a fundamental API design question for Cozy is, do we want to do our auth control that way by adding a dependency on a third thing? That even if we believe there's many compatible implementations of it, or do we want it to be standalone such that, Kubernetes and Cozy can by themselves just always give you an access key and a secret?
I mean, can it not be both ways?
Yeah, but it doesn't change anything, right?
Well, no, I'm not saying you can't do the other way, but I'm saying like this is a fundamental question of like when we were designing the Cozy protocol at the beginning, the whole reason we had BARs and BAs was based on the assumption that it's Cozy's job to mint a credential and own that process. Like what you're saying now is that credential minting is no longer necessary, right? Because you have some external authorization provider, and all you have to do is register some principal as having access to a bucket, and you're done. And then all of the actual, authentication is between the workload and the OIDC provider and the object storage, and Cozy gets out of the way, right? You wouldn't even have to provide any information to the pod other than the bucket identifier. So like we could go down that path, but that's a very different design choice than we made at the beginning.
No, but I think there is something to provide, which is currently there. it is not clear what is the standard to do it, if that's what you want for object storage, right?
No, I don't think we
Like
should go the
drivers don't
OIDC
know.
though. Sorry, I don't think we should go the OIDC route. I think there is a simpler way, even something that we can implement, which is a metadata service. That's what AWS calls it. That's what GC calls it. And what is this? OpenStack also had this, a metadata service that is on the link local IP address, which is 169.254.169.254. You query it and you get some responses back about yourself, about your workload.
Yeah, but that
And
would be a
depending on,
Kubernetes-wide service that you'd be proposing
yeah,
that would
that's
always
the
be
other
available
problem.
everywhere.
Yep, yep.
And there's security implications and all kinds of other implications
No,
to.
no, I know there are problems to it, but it's not something that's impossible to do.
No,
Um,
no, I don't think we would want to throw that hurdle in front of ourselves for getting Cozy
Agreed,
accepted.
agreed, completely agreed. I'm just saying how things happen in Amazon, I think right now our current decision of going with access keys and secret keys is good enough for alpha.
Yes.
And then credential rotation is not something we are locking ourselves out of. Just like we just discussed just now, we have multiple options. One is OIDC, one more is metadata service, and I'm sure more options will come up. Um, but I don't know if we should spend more time on it right now.
Yeah,
Uh,
let's not spend more time. We just need, at this point, we just need to have an idea what we want to do next, like some kind of roadmap. But for now,
Yeah,
for the alpha version, we don't need to solve that. I don't think so.
yeah, sounds good. Ben, were you saying something?
Yeah, I was just going to say, almost you'd rather not have an idea what you're going to do next, and to focus on what you are going to do
Right now?
for alpha, and then
Right.
maybe revisit this after we reach a stable alpha, and let someone propose a working solution. Because yeah, it seems like there's a lot of options, but they all have hidden drawbacks that until we give them deep discussion, we're not going to become obvious.
True. True, and it's not the highest priority right now, so
Yeah.
I think it's okay to push it back a little bit. Okay, so the next important thing is actually API review. So we're still waiting for Tim to get back to us. If any one of you get a chance to talk to Tim, or if anyone of you can help with reaching out to Tim, it's much appreciated.
So what is your strategy to get a hold of Tim?
So generally he responds to my emails.
Okay.
But last time he responded was 2 weeks ago. Then I sent him one
Okay.
email. He said he's going to be busy. That was the last week, and this week he hasn't responded yet. So I think.
Yeah, but what I do is I typically just resend the email after a week if he hasn't answered, understanding that it probably got queued and then fell off the back of the queue, and so you got to
right.
push it back onto the head of the queue.
Yeah. All right.
He's never gotten angry at me for doing something like that.
Oh no, I don't think he's ever gotten angry with me. He's really nice. Actually, I think he's gotten angry once. Never mind.
but yeah. I mean, if you want to get a review going, just remind him periodically.
Right.
I think that's the best answer. I need to do the same thing with my KEP. So I'm going to start pestering him myself.
Okay. Good luck. We're on the same boat right now.
Yeah.
Okay. So it's going on in parallel. Reaching out to Tim, that is. I think the KEP is in a decent place. Let's ask Jeff. Jeff is here. Hey Jeff, are there any updates left to be made on the KEP?
No, I haven't updated it in a while. In fact, I haven't addressed directly Sebastian's comments from a week or two ago, although we've discussed them a little bit. But really, my personal feeling is the PR for the KEP is getting too large and unfocused. And what I'd like to do is just get that PR merged, and then we can go on from there and make additional changes. We can explicitly They were not dealing with cert rotation or whatever we want. But right now we've got a lot in the PR and it is just stagnating, I think.
So Jeff, if it's getting too large, that suggests maybe some of the content should be moved. I mean, maybe we should move the bulk of the content to another location and make the KEP somehow a summary of that other information with pointers to it, of course.
Well, first of all, aren't all KEPs pretty much so? So the too large part, Ben, I believe is from the number of comments that are there on it.
Yep.
And it takes a long time for the page itself to load. In terms of content, I think we're pretty standard, just as much as any other KEP.
Yeah.
Okay.
Yeah.
Yeah, I agree, Sid. I mean, the KEP is large, but the problem's big, so it seems okay to me. It's just this PR that makes that defines the API change that we did related to buckets and BARs, right? Is described in the KEP PR, but it hasn't been merged. So if someone was looking at Cozy, all they'd see is the KEP, and they would, just be missing the last month or so of dialogue that this group
Okay.
had. Maybe it's.
I see. So you mean the updates after we had the discussions about bucket mutation and
Right.
that kind of thing? Okay. I know we updated the API. Maybe we haven't updated the text around it. Is that what?
There's just been, I mean, there's been the change to the API that we went over quite extensively. There's minor changes to the RPC, messages, and there's some improvement or clarification in general workflow. Just things like that. There was fields that we did, I think Ben said there wasn't a particular field that was needed anymore. We agreed maybe it was anonymous access or public. Anyway, all these discussions we've had in this meeting are reflected in that PR over the last, maybe it's 2 months now. And, but the PR hasn't been merged yet. So they're not actually in the KEP.
I see.
Right, but
Okay,
isn't merging the PR identical to approving the KEP?
Well, the KEP's been approved. So this is a PR. The KEP's already approved and merged, and it's in enhancements.
I see.
Right,
what you're
but
saying. Okay.
in what state? In the provisional state or in the implementable state?
No, in the state it was like 10 months ago. So
okay, so what we need is for it to be implementable in 122.
Right.
So that we can actually get to alpha.
Yeah. So Jeff, I see what you're saying. When you use the word KEP, you mean the merged part of the repository, not the PR.
Yeah, I might have said it wrong. All the comments I was just saying was about the KEP PR, the current open PR that I've been working on.
Right. Okay, makes sense. So what updates need to be made in the PR? Do you know? Are there any?
It needs. Perhaps we want to directly address some of Sebastian's points.
Okay.
We could discuss that separately, but then it needs the approval. The PR needs to be merged into the KEP.
But does the PR mark the KEP implementable?
Sid, do we?
Yeah.
Does it do that?
Yeah.
Okay.
Yeah.
Okay, because that's the key change, such that if the various API reviewers, already approved what is merged, and they additionally approve this new PR, and they say it's implementable, then that's the green light to try to get the code in.
We don't have that because I think we need Tim's API review for that, right?
No, I think we can set the implementable to be true, and then if they approve it, then it just becomes true.
It's in the KEP YAML. There is another file.
Yeah.
It's just
so we need to make sure that the new PR makes that change so that the act of approving the PR means it becomes implementable.
All right, that's a good point.
Also, you need to start the production readiness review.
Do we need to do that for alpha?
Yeah,
Just
yeah.
publish no
Alpha is
Yeah,
easy, but you need to do it. Yeah, you can take a
Okay.
look at some examples.
Yeah, I think we saw some, and I think we
Yeah.
wrote a little bit of it. I think at least we talked about it last time.
Yeah, you should have that
towards the
section
bottom.
actually. That will, you probably already have those things, right? You probably already have those section there, just didn't fill out.
yeah. And do we have a PRR reviewer identified?
Tim.
No, he's the API reviewer. Like,
Oh, I
Yeah,
see.
you
There's
need SIG
another.
storage as well, right? This is yeah, you probably already have that. I think you already have that somewhere.
Okay, so it should be marked at the
It's
top.
probably in the cap. It's probably in the cap, that file, YAML file.
but for the
Oh, I
product
see.
readiness, there's like a specific team, and you need
Oh
to get
yeah,
one of those
that one
guys
they need. Yeah.
to do the
Okay, so you already have.
PRR review.
Do you have production? Looks like you don't.
Oh, that
Yeah.
might be here. Let me see.
Yeah, so change the status in that cap.yaml to implementable, and then you need to add someone from the.
Yeah. So I just have the README file. So we need the kept.yaml file in this PR. It sounds like, right?
Yeah.
And I think there's also a special file for the product readiness review in another directory.
Oh, it's a separate file. Okay.
Yeah, there's a separate
Yeah,
file in a separate directory for the PRR, and it's essential. It's not hard to deal with. You just got to add it to the PR.
Sure. Yeah. We can do that. So I'm guessing let's take something that's already been done. Local persistent volumes and production readiness.
You need something that's been done in the last cycle or three, because this is a relatively new process.
I see.
And so
okay,
older keps
volume
won't have it.
populators.
I can find you an
populators is-
example if you don't. I have an example. Let me just. I need to find it though.
Looks good as a template here.
I think I just look up like this. Prod readiness. There it is.
Yeah.
Okay, just to give you an example, you can take a look of this. Yeah, just this one.
This one, right? Okay.
Yeah.
Okay, so it's a separate file under a different directory.
Right, and it has the name of the person from the PRR team who is doing the review.
I see.
So yeah, for this, you actually what you do is, once you are ready for them to review, you just go to the Slack channel, and then you pin them.
Storage. Okay.
And then one of them will come and do it. So I think you can actually add the name later. I think it should be fine.
The Slack channel is called prod-readiness.
Okay, got it. Okay. All right. So everyone here though, can you take a look at the comments made by Sebastian and see if it's something that we should respond to, and if so, help us respond to it. I think Sebastian joined us a few times here. His handle was Hansler N or Hansler S. He joined us at the meetings a few times. Yeah, Hansler SN.
Yeah, that's it.
Yeah. So what was this question about? If BA cannot exist without BAR, then why does BA exist in the first place? Couldn't you just simply merge BA and BAR into a single resource? Yeah, it's because we want to separate the actual secret from the request for it. PV exists because PV can exist without POC, either because it's statically provisioned or because you want it to. Okay. Bucket exists because bucket can exist without a bucket request, either because it's statically provisioned or because you want. Okay. Can neither be created without a BAR, nor is there a need to retain it, as there's no reproducible state associated to BA. I see what he's saying, but we want to do this in order to kind of, yeah. So this brings back the question that we had last week. Our original idea was we want to put BA in the global namespace so that not everybody can just read it. But really, they can read it in the same namespace by just mounting the bucket. So does that argument still make sense? that BA is separate from BAR. I mean, I'm sure the decisions we made had good reasons to it, and his argument probably doesn't, you know, he probably hasn't thought through everything, but we need to go back and remember why we made this decision. Oh yeah, there is a use case. There is a use case. We do create BA on its own when we have static credentials and we want to provide static credentials to the user.
The brownfield case.
Yeah, yeah. And I've written it down too. It's a driverless use case. And let's see. The user may not have access to policy actions config map. Also in the cozy meeting, there's a discussion about removing the config map. Yes, this is the kind of thing I'd like your help with. Please take a look at the KEP and help us answer the questions, or if you have any suggestions or improvements to make, you can directly make a PR or bring it up in the next meeting. And that would really help us move this along faster.
Yeah.
While we reach out to Tim. Yeah. So I would like you all to just take a look at the KEP. I've pasted a link to it in the chat, and just go through it. See if there's any question or comment that catches your eye. There's any section that catches your eye, and make sure everything looks good. And you know, bring it up if you have any questions or suggestions. Like I just said, that's all we need in order to move this forward. All right. So next is development. So we've actually been moving at a pretty good speed in terms of development. We created the repo that Vianney and someone else were suggesting, Guy, I think. So we've created a sample repo called Cozy Driver Minio, and we've already started moving the driver code into this. And in this repository, we have scripts that show you how to deploy a driver along with the sidecar, and anyone who's looking to write their own driver can actually look at how this is it's done here, and then just follow the same process for their driver. Now the sidecar, which originally had this driver repo, now doesn't have it anymore, and doesn't have a deployment YAML right now, because you can't just deploy the driver, the sidecar without the driver. So from here we've taken out the customize.yaml and the YAML files really, and this repository just houses the provisional sidecar. Any questions so far? All right. So so today a pull request was made by Yanis. He's not here right now, but he made a pull request to add to implement grant access, and I believe also revoke access. So I would like more people to be involved in the review process, so that you're all familiar with the code, especially as some of you might start implementing your own drivers, or making more changes to the architecture. It'll really help and speed things up if you're already familiar with the code. So this is a good PR to start with, and if you also subscribe to our projects, you'll be able to get more notifications about the pull requests that we're making. And I welcome everyone's reviews. I mean, as long as we're all aligned with the fact that we want to move forward, everyone's reviews are welcome. Because it's happened before where PRs go stale simply because people are contentious over what's the right approach, when either one might work. So yeah, so in terms of development, that's what we've got. The thing that we haven't finished developing is the finalizer lifecycle for I believe buckets and bucket accesses. Krish, could you bring up again what you told me yesterday?
Yeah, so right now in the sidecar, we're not really creating finalizers for buckets and bucket accesses. So like things can just be deleted. So we added the finalizer logic to the CSI adapter. That was kind of the first step. So now when you create your workload and you mount, the secrets for your bucket access, it adds those finalizers onto the bucket access for the pod with the name and the namespace, and then it removes it when the volume is unpublished. And so we just have to add similar logic to the sidecar in order to add finalizers everywhere where relevant. So I guess, yeah.
So, good.
Oh, I guess that one other thing that it'd probably be good to do is also add finalizer onto the secret that we create.
Oh, yeah, that's a good
I
point.
just forgot about that. I realized that when I was talking about it.
Yeah.
So would we have one finalizer per pod?
No, please no.
Okay.
Right now, that's how it's done, but it needs to be improved. I agree. So, I ran some tests. So Ben, last time my pushback was that it should just work, and unless there's a problem, why should you optimize? And I ran some tests, and I can tell you it leads to a lot of conflicts. So it probably won't work. It's probably going to take 10 minutes before you can actually make one update to a pod finalizer. So that's not going to work. So you said we maintain a local data structure which is based on the informer of the current pods that are using it, right?
Basically, yeah. The thing that deals with this finalizer will have to have a pod watcher in it. And yes, that's a scaling concern, but like there's many other things in Kubernetes that have to watch pods. So this is just one more of those. And yeah, the idea would be you have exactly one finalizer that, and then the controller is responsible for knowing comprehensively, if there's any pods using it or not. And then when the last one is gone, that's when you remove the finalizer. And you have to ensure the property that like when it's in the deleting state, nobody can bind. That's the key, right? So you have a one-way ratchet on the way down. Once it enters the deleting state, you can only unbind and not bind.
I think that part is okay. That part is easy to implement. You just check for the state, and if it isn't deleting, I mean, if the deletion timestamp is set, you just don't do any operations on the bucket anymore, like binding.
Right.
Yeah. Yeah.
Sorry. In your testing, was the issue the number of finalizers?
No, it was the fact that I was doing the number of updates that were happening, number of pods.
Because otherwise we could keep a rep count, but then you'd have the same number of updates.
Well, yeah, there's that, but also yeah, and the same chance of conflict. Yes, it doesn't make a difference at all. In terms of the conflicts, it's very heavy on etcd. If it needs to lock and check that whatever update you're making is actually the right update given what the current state is. It's better to do the local data structure like Ben is suggesting. I see that's kind of the only approach that can work at this point, and scalably. And I think, Ben, you also suggested at one point we should use the patch request instead of the update. I'm not so sure patch will do the job for us because patch doesn't account for it doesn't make sure that any updates you make is on is only done if the previous version of the resource matches the version that you're sending back.
Well, so this is one of the horrifying things about the Kubernetes API. There's 3 different formats, maybe even 4 for patches, and they offer different capabilities.
Okay.
There's like an ordinary merge patch. There's the strategic merge patch, and there's the JSON patch. Right. And with the JSON patch, you can put a bunch of test statements in your JSON to say test if this equals that, test if this equals that, and then if any one of those fails, the whole patch fails. So what you can do is structure your JSON. You can use JSON patch and structure your JSON patch to enforce whatever invariants you want, like the resource version must be this, or the old value of this field must be this, otherwise the patch fails. and then of course you'll still race with other things, and sometimes you'll lose those races and your patch will get kicked out and you'll have to generate a new patch.
About this patch, we were actually trying to do this for the snapshot because we started with update. Then we thought, okay, going with the patch is going to reduce the number of failures. But however, after we switched to that, so we can also do the JSON patch. But after we switched to that, but then we tested, we found that didn't reduce at all. So we're still trying to figure out why. And if anyone knows,
so I ran into a similar problem with one of the projects, the CSI driver that I'm writing, and the issue is the retry mechanism. Actually, we just made a pull request for this. So random selection of filter drives. So what we do is, we match drives to a request, and for this, if a pod requests 100 drives of the same kind, then all of them match to the same resource that's available. And the problem is when the retry happens of the create volume in this case, when the retry happens, the retry for all 100, when you ask for 100, only one succeeds. So the retry for the rest of the 99 all happens at the same time. So the likelihood of failure is high again. So we just added a tiny bit of randomness.
Okay.
And that fixed it. It's like
okay. Oh, so you're fixing that this way. I was trying to see if there was any.
But it sounds like there's a different underlying problem there, where you had a bunch of requests too close together in time, and adding jitter spreads them out across time, and that's enough to solve it. Xing.
So in this, in the problem that she's describing too, finalizers, get into this problem because we start with a version of the resource, and then on top of that, we apply the patch. It's the starting version of the resource that should be different from what everyone else's starting version was. So
it should be or it shouldn't be. I mean,
but so I guess the answer I was trying to get is that I know that if it's not a CRD, if it's an entry resource, right? If you use patch, actually it will reduce the number of failures when you modify
I think it really depends what you're trying to modify. Like there are certain types of changes where you only want the change to succeed if the resource hasn't been touched since you looked at it, because you looked, because the change is dependent on certain fields being set to certain values, and if anything changed, you want to take another look at it before you decide what to make the change. But if all you're trying to do is like remove a finalizer, you don't care what the rest of the state of the object is. You only care that the list of finalizers hasn't been touched since you looked at them, and you remove one element from that array, and reduce the length by 1, and any other change to the object, you don't care, because all you're trying to do is remove a finalizer. And so you can structure a JSON patch with a test statement and a remove statement. I have an example somewhere of how this works, and you don't care what the resource version was for that specific case. There's other cases where there's different considerations. But
okay, so I want to understand what this looks like. So we can't do the test based on the number of finalizers. We can do the test based on if all the finalizers match exactly what I've got here, then remove this. But see, if I were to make 100,
that's okay. So I'm looking,
only one would succeed. Huh?
Go back to where the patch was. Okay, so you have a replace.
Where am I looking at?
Down.
Oh, this one.
Stop. Okay, yeah. So this has 3. It has a replace and an add, but no tests. So I'm going to see if I can dig up my example of this, because I spent a lot of time goofing around trying to get this right.
Okay, now if you prefer YAML to JSON, the patch can be expressed in YAML format. Okay. Multi-patch demo. Let's see. Patch is path. Okay. Target, group, version, name, kind, namespace, label. Okay.
Okay. You mind if I share my screen?
Yeah, please go ahead.
I'm probably gonna get denied because I'm not a co-host. Yeah.
Oh.
Please make me co-host.
Send a link. Yeah, go ahead.
What?
I just have. Link, I can show.
I just have a. Oh, that might work. Send the link. Yes.
On chat.
It's gonna take me a second to find the link, but I'll get it. Populator machinery. Chat. There's the link. All right, this is how I do it. So I have a method. This is inside the data populator library called ensure finalizer. This can either add or remove finalizers from a list. And the want means it should be added, and that's in which case there's only one element of the JSON patch, which is an add. But the not want, it does a test that the element so it's looking at the it scans through the list of finalizers in the list. It finds the index of the one that it wants to remove. It has a one test element that tests that element of that array is equal to the value of the finalizer that we want to remove, and if so, it removes it. So adding it is a simple one element JSON patch, and removing it is a test and a remove.
Well, add also would need to check if it exists, right?
Well, yeah, but that's what the logic above does. So if you scroll up, it actually scans the array.
Oh, if found is true, then what does it do? Found ID is that, and then if found equal to wanted. Okay, yeah, makes sense.
I guess. Well, okay. Yeah. It is possible for two instances of this to race with each other, I guess, and add the same. So then what you would want to do is have it test for the resource version, or.
Well, no, just test for the existence of this. The existence of whatever you're adding.
But the problem, here's the problem with JSON patches. The list of finalizers could have 10 elements, right? And you're adding the 11th element. So the way this code is written is, you'll get the current version of the object. It'll scan through the 10 finalizers and say, okay, the one that we want is not there, so we need to add it. Because if it was there, you see on line 712, it just returns. It's done, right? If the finalizer is already added or already removed, the function returns. But if it's not, then it constructs a JSON patch, and what this will do is it'll add the 11th element to the list of finalizers.
Yeah, except you want to be synchronizing with the data in the backend. So between here and here, I could have added the finalizer already, and when you do this again, you're adding it twice. So shouldn't you be doing the test in the JSON patch?
The problem is what you would have to test is that all of the other 10 elements don't have the value. Because an arbitrary number of changes could have happened. If at the time you looked at the list of finalizers, there were 10, but between the time that you did that get and you send your patch, there could have been 10 updates to the object.
So and look for certain finalizers.
A whole bunch of finalizers could have gotten removed and added in that window. And yeah, all you care about is you want to add yours to the end of the list if it's not there.
Is this really more efficient than just going with an update?
I don't know.
Yeah, I don't know either. I mean, I know resource version is heavy, but really,
it seems to me that an update might be good because you do a get of the resource, you look through the finalizers. If it's not there, you add it, and then you update. And if the update fails, I think there's you can figure out if it's because you don't have the latest version of the resource. I forget what they call that error type.
Yeah, the problem with updates is if you have an older version of the resource than the API server has, you just end up zeroing out fields that you didn't want to zero out, and so it's not an error; it's just a loss of data on the object. And I don't even think Kubernetes has a way to protect against that. It's just a bad possibility that can happen.
I've seen messages before that say that the update was applied with an older version of the resource, but
doesn't it just fail with the mismatch of resource version?
Right.
Yeah,
so we're talking about two kinds of versions. There's the etcd version, which is like the generation number of the object, and if you're doing an update versus an older generation of the object, it will fail just because updates have to be against the most recent generation. But there's a separate problem where an actual versioning problem where the struct that represents the object got a new field, and so the CRD that the API server knows about has a field that your code doesn't know about because you're running with an older version of the struct. So when you send an update, it will omit the whole field because your code gen, is using an older version of the struct, and so the JSON marshaller will just omit the field entirely, and so there could be data that you'll be dropping from the object because it was a different code version, and that's one reason update is looked down on, because update causes that problem, and nothing detects when that happens. It just happens, and then the field is empty now.
Gotcha.
So people prefer patch because it works around that particular problem. Basically, you just don't touch fields that you don't want to touch.
Right.
But yeah, I think you still maybe can't get away from doing a test on the resource version for complete safety. In which case,
this function can race.
It can race. Yeah. So I think we found a bug in my code. I gotta fix this. But yeah, in principle, a JSON patch should be powerful enough to do what you want to do, and yeah, if there's races, you just have somebody has to retry whoever loses the race. So the best thing to do there is minimize the number of updates and patches.
Right, or concurrent updates on the same resource.
Yeah.
Hey, I have a question here. So that's why the random listing. So, but I have a question here. What was the reason again for not using updates and preferring patches?
It's in the situation where you have an object that, over multiple software versions got some new fields that are optional.
I see.
When a new controller populates those fields, and then an old controller tries to do an update on that object, it will drop the contents of the new fields because it was compiled without those fields in the code.
Yeah. So yeah. Okay. So we addressed that by actually, in all of the API requests in Client Go, in the options you can provide the API version, and it only works with that API version.
Right, but the problem is sometimes people add new fields without bumping the API version. If you're scrupulous about always updating the API version, you're fine. But the problem is once you reach V1, like there's nowhere to go, right? You'd have to go to V2, and nobody wants to do that. So what they do is they sort of add optional fields to the V1 API while it's still V1, and they don't bump the version. And they say, well, it's still V1. We just added a new optional field.
I see.
And you end up.
Isn't that the idea behind like going through alpha 1, beta 1, as in you solidify it more and more as you go forward?
Maybe. I mean, you have to. This is a question for the Kubernetes API guys. That it is common practice to add new optional fields to V1 objects. And
can you have dots in the version name? I think you can, right?
No, I don't think
Probably
so.
Not. Okay. If so, then we could do semantic version. We could be like 1.1, 1.2.
No, it's they go like V1 alpha 1, V1 beta 1, and then V1, and you can have V1 beta 2, V1 beta 3, V1 beta 4, but once you get to V1, there's nowhere to go except for V2.
I see.
And Kubernetes has resisted going to V2 for anything ever.
I mean, it kind of makes sense. V2 is supposed to be for, like, when you jump major versions, it's basically supposed to be for, breaking changes. So
yeah. So the idea is you make these non-breaking changes by slipping in new optional fields, but then you're screwed by the semantics of updates.
Right.
And so patches are the way to work around that.
Right, makes sense. So okay, so we're almost out of time, and in terms of implementing the finalizer, I think we'll do an experiment. We'll try the patch method. We'll see how it works out. But really, the only way to avoid conflicts and reduce the amount of time it takes for this to converge is to space them out. Even with this patch, you're going to conflict anyways if you test, and even with the update, you're going to conflict anyways if if you have multiple updates to the same object. So
right. So for Xing's concern that she raised a minute ago, maybe the right investigation to do is to see why there's concurrent updates happening or concurrent patches happening. And if we have the same problem in Cozy, like first investigate the why rather than the mechanism for working around it.
Right.
Yeah, that's a good point. Probably we should actually dig deeper just to see why we're getting those. Yeah.
Yeah, in our case, it was because the retries were happening at a regular interval. every retry, all of them started at the same time, like after.
Right. Yeah. So just having jitter in your retry
right
is a really good practice.
And that's all it took. Anyway, so we're almost out of time. I think we can end here. So, Ben, or anyone else, if you want to work on this finalizer logic, we need people to start contributing code for stuff like this. Ben, since you've already worked on this, would you like to take a stab at it in Cozy, the finalizer thing?
Why? So I've just realized after this conversation, I need to fix my code in the populator thing. Yeah, like if I get this to work better in the data populator library, yeah, there's no reason we couldn't copy paste it into Cozy. I'd be happy to help with that.
Okay.
I don't want to sign up for any heavy lifting
Dev.
coding tasks because I'm also signing myself up for a whole new feature in 122.
Okay.
So I'm going to have three frying pans on the fire, and it's going to be rough.
Yeah, I understand. It's okay. But anyone else, if you have some cycles, your contribution is welcome. Just like Yanis has been making pull requests, he is not able to join the meetings because he's in Ireland, and it's really late for him. But he still makes contributions. So more people are encouraged to do the same. And yeah, you can reach out to me or just message on the Slack channel, SIG Storage Cozy, and someone will help you, or if not, I'll help you get started. That's about it for now. One last thought is, if any of you get a chance to reach out to Tim, or if you can help out with reviewing the KEP, please do so. That's all. Let's talk again on Monday.
Awesome.
Thank you. Bye-bye.
Thank you, everyone. Bye.